Maritime Made on Eastlink TV is presented in partnership with Nova Scotia Business Inc., Nova Scotia's business development agency.
There was a time when all a boat needed was the wind. But with global trade, as well as faster and larger boats, there came the invention of the motorized boat. And with that, the propeller. Today, most large boats have a propeller. And when it comes to large propellers, the folks at Hawboldt Industries in Chester, Nova Scotia, make some of the finest. In fact, they've been doing it for well over 100 years. Large propellers are usually made from cast manganese bronze, a strong corrosion-resistant metal made from copper, manganese, aluminum, and iron. The bronze is cast in a unique sand mixture that, with the help of binders, is able to hold its shape without falling apart. Hawboldt recycles their sand as much as possible. So the first step is to aerate the sand. For this, they use the sand cutter, a machine that simply mixes the clay and sand together. A worker will also add water to keep the sand moist and firm. Propellers are molded in two-part boxes. Once aerated, the sand is shoveled into the top half, known as the cope. A template is painted with zip slip, a special template release paint. Then, it's placed inside the box of sand. The template is an exact replica of the final propeller. Hawboldt stores hundreds of templates, most made from aluminum. Each represents a specific size, blade configuration, or blade pitch. Two workers place the template inside the cope, making sure it's centered and level. They then place more sand in the cope to secure the template. Next, the bottom of the box, called the drag, is placed on top of the cope. A riddle, or sift, is used to remove any debris from the sand that will lay directly on top of the final propeller. As more sand is shoveled and then compressed around the template. A worker uses an air rammer to pack the sand as tightly as possible. Once the template is set, a horn is placed on top of the template. This will form the pour hole once the mold is complete. After much more shoveling, packing, and compressing, the final mold will hold about a ton of sand. Finally, a worker uses good old body weight to compress the sand. Workers use the strike to rake off the excess sand before nailing and clamping the bottom lid. The next steps require the entire box to be flipped over. Once that is done, the lid and the cope are removed, called breaking it open. The top sand is now removed to reveal the tightly packed template. Next, the sand is hand-tempered and molded around the template. The mouth of the horn is also uncovered. Parting is then shaken onto the entire surface to ensure the two halves of the final mold don't stick to each other. The cope is then placed back on top of the drag and clamped. Gaggers are added to give strength to the sand in the final mold. A pour pin is hammered in to connect with the horn, and a draw gate is carved by hand. More sand is sifted onto the top of the template, then shoveled and compressed layer by layer. The sand is scratched after each compression to ensure each layer sticks to the next. Finally, a spacer and riser are used to create a space for shrinkage in the final pour, and more sand is added. A vent wire is used to punch an air hole in the sand. This will allow gases to be released during the pour. Once everything has been packed, the pour pin is removed, and the cope is slowly lifted from the drag with all the sand still inside. The cope is placed on its edge so that workers can gently remove the rough edges of sand, as well as cutting out the area where the spacer was. A worker also removes the template and horn. Once all the remaining sand has been cleaned and dried using a flame, the two pieces are clamped back together, ready for the pour. The manganese bronze arrives at Hawboldt in large ingots that are placed in one of 3 large furnaces. In this case, an electric arc furnace that's capable of melting up to 600 pounds of material. Once the metal has heated to its melting point, about 1900 degrees Fahrenheit, workers remove it from the furnace and scrape off the top layer, called slag. Finally, the molten material is poured into the sand mold. Once complete, vermiculite is used to cover the riser to ensure minimal shrinkage as the metal cools. Leftover metal is poured into makeshift ingot molds. Once the molten metal has cooled, usually within a few hours or overnight, the box is opened and the sand removed, revealing a shiny yet rough propeller. Once removed, the pour hole and riser are cut off by hand. A worker uses a lathe to drill a tapered hole in the center. This is where the shaft will be attached. A key is also cut and will ensure the propeller doesn't shift on the shaft. Once the holes have been drilled, a worker grinds the rough edges off, starting with the edges and moving to the flat surfaces. Finally, a propeller's pitch needs to be checked to ensure it meets customer specifications. The pitch is measured by the distance a propeller would move forward in a single rotation. If the pitch is off on any blade, the worker heats the blade and uses the pitching tool to make adjustments. Once the pitch is set, the propeller's balance is checked. If a specific blade is heavier than the others, a worker will grind the heaviest blade down until balance is achieved. Once balanced, the propeller is finished using various fine grit sanding discs and is then ready for use.
Maritime Made is presented by Nova Scotia Business Inc. because great things are happening.